Okay, guys, so if you want to try it again, so go and clone this repo. It's on Hoover. During the next, do you want to make intro?
No, it's fine.
Okay.
You already started.
Yeah. Sorry. And during the 10 minutes, I will make a very quick introduction to SQL on FHIR and analytics on FHIR. It's going to be really quick. So why? Because more and more data are available in FHIR format. Just think about like bulk export and all this stuff. And we definitely want to start reasoning against this data, yes? And that's the main motivation. Another motivation, yeah, the FHIR is a good format for the storage. That's my opinion. You may disagree, but FHIR is generic enough so to like, and you can store a lot of data. And then it would be nice to start querying this data. Arjun already told there's a renaissance of databases, like every week the new database appearing, and it's getting faster, better, and so on. So, and we, in SQL on FHIR, we definitely want to build a bridge between the modern databases and the FHIR data. So there was first version, but because modern databases can store nested data, the only problem that the different dialects, so it's very vendor specific, it's very technology specific. So we try to standardize it, it doesn't work. So for now you can write the queries in like this in BigQuery, in Postgres, but these queries are completely different. So nothing to standardize. Yeah, but for you just to know that modern databases can store nested data structures and you can query them very efficiently. And that's what most advanced like engineers doing for many years. Yeah, but we decided, okay, maybe let's simplify the stuff because like all the people start asking for something flat. So give me the tables, then the tooling understand, and people understand the like IDEs can suggest tables. So we got this dream team, and we built the second version of SQL on FHIR, where the general idea we can write a DSL which will flatten the FHIR. Yeah, I will jump quickly here. So the idea, you have a FHIR resource, you're writing FHIR path, you extract some elements and put into the columns, yeah? So it's very straightforward. And we decided to build it on top of FHIR path, but essentially subset of FHIR path, so people can easily implement what we call runners. Runners getting resource and transforming them into flat representation. It is lossy conversion, but we understand this, and there is no like universal tabular representation of FHIR. If you can try to do this, you will get like 1,000 tables. So you could not work with these tables, yeah? So it is lossy, we're just getting flat stuff, but it's still very useful. For some use cases, you can imagine, you can build like a blood pressure table with systolic, diastolic and start querying. Yeah, and we understand that there's a lot of use cases when this lossy transformation is still very valuable. And all the views are going to be use case specific. Okay, so that's how it looks. So we put this DSL into the JSON FHIR resource, and it essentially describes which fields I should extract and how to make them columns. This is just quickly stuff. And then you can start querying these flat tables. So imagine you apply your runner applying this ViewDefinition to FHIR resources, you're getting CSV or just getting data inside database, and then you can start using like flat SQL to query that. Something like this. Yeah, and the ViewDefinition DSL is very simple, it's just like 5 functions. So the first function important, it's a column function, it has a FHIR path which says which element I want to extract into the column. The where statement element, it's just a FHIR path expression to filter out resources of your interest. For example, you can filter by profile or by specific law in code and observation, and you can transform only specific resources. Because FHIR is very generalized model, yes, so, and here what we're doing, we're specializing it into the flat representation. The forEach, it's essentially unnesting. So the idea of the forEach, it's produce multiple row for every resource. And the select is required for forEach, so you can like cross-join top-level elements with the elements you're unnesting. I understand it's hard to understand. I will show you examples. And the unionAll just union two sets of rows. So for example, here is a column. We say at the top there is like sample data, and then the view definition which say take ID and take family first. And then you're getting something like this. So it's quite trivial, yeah? So we're using subset of FHIR paths to be easily implementable. So it's not full flagged FHIR paths. It is possible, but the specs say that it should be the subset. Then you may say the where, it's clear as well. So you're just filtering by some criteria in FHIR paths. So we filter out the females out of this list. And the forEach, you see we have two resources at the beginning, and then we want to forEach by name. So it will take every name element and produce a new row for each element in the collection. So you see that we started with the two resources, but at the end we have three rows. That's how you can unnest the nested data, like nested collections. And the select is usually using with the forEach because we want to add the patient ID to every name we unnested, and it's doing this lateral join. So strictly speaking, it is a lateral join. So, and that's how you can join the nested elements with the top level elements. And the unionAll is quite trivial. So let's say you have multiple collections from the telecom and the contact telecom, and you want to join them into one table. You can just write two for each, and then you just union them all. So that's all. Now you know the SQL on FHIR. We finished. Yeah. So it was fast. Yeah. So. This year we released the first version of the specification. So, and the part of the specification is a good test suite where we're providing a data set, the view definition, the results. And the implementers run this test. So this is like standard test suite. And we have a nice, let's go SQL on FHIR.org. We have a nice view of the test, so you can walk through the test. You see this, the data set, then you can open specific view definition, and then here's what's expected. So for example, the collection true, maybe let's take something simple like basic stuff. So you see, here I'm just taking ID, it's getting ID. Yeah, I'm taking active, and it's getting like this. So, and then we have a matrix of implementers who run this test and report back the results. And you see this is all implementation of SQL on FHIR. That was done before release. That's kind of unique situation. So we not top down, we bottom up guys. So before the specification was released, we already have a set of implementations. And that's how we're doing guarantee that the implementation are compatible with each other. So this metrics, not all the stuff supported, but like most of the green, yes. And the Graham didn't publish the results. Graham built this SQL on FHIR runner into Happy in memory, but yeah, somebody will help him to do that. Okay, so what else? Yeah, so about the runners. So we see there's like two types of runners. One runners which kind of easy to implement. It's like, I call it ETL. That means they take stream of resources, applying the view definitions, producing rows. And for example, they can store CSV, or they can write into the database. And it's quite trivial to write such type of runner if you have a FHIR path implemented. It's a little bit less trivial to write if you don't have a FHIR path, but because we have a subset, so people reported they were able to write this runner in Rust, for example, in a month. So it's reasonable amount of time. So, and there is open, like the part of the specification is a reference JavaScript implementation of it, which is just like couple of pages long JavaScript. So if you decide to implement the view runner in your language, just take a look at the JavaScript implementation and use your technology stack. You're lucky if you have a FHIR path engine. If no, you will have to implement subset of FHIR paths as well. And there's another type of runners, which I call ELT, and then they're more like transpilers than the runners. So they taking view definition, and for FHIR native databases, they translate the view definition into the sophisticated SQL query, which can produce, and you can run it inside database. It's much harder to write such type of interpreter, but we have a couple of them. So the one is ours for Postgres, and another by Dan, it's flat for the DuckDB, which translates the view definition. And then if you have a FHIR native database, you can just create a normal database view using this generated query. But we will see soon how it works. Yeah. Yeah, so this is kind of future what may happen. So we all know the bulk export. Yes, so you're asking FHIR server to do the bulk export. You're getting this data. You're running this through ETL runner. You're getting CSV and probably loading into the database and start querying. And this is like low-hanging fruit, so you can start using SQL and FHIR. And the Bashir is here. So there's like again, so the bunch of implementation of ETL stuff. They're already in production. So just pick one you like and test it. Okay. And this is like ELT runner, which transpile to SQL, and everything happen in database. Sometimes it's much more efficient than running in the memory. And you see here, for example, oops, no. So this view definition is transpiled into such type of query. So before that, you can write this query by hands, yeah, but it's much harder than just give this declarative view definition and the compiler will do it for you. Okay, this is another talk. Yeah. Okay, so yeah, last year we have an Analytics on FHIR conference, and we're gonna have it this year. It's free online one-day conference, maybe 2 days. Maybe we'll do more on LLM and AI stuff this time, but check the LinkedIn, we will publish announcements. And there's recordings on YouTube about this conference, so if you want to know more about like different implementations and vision, so just Google for Analytics on FHIR and see the YouTube videos. Yeah, for this year, we're working on a bulk export API. So the general idea, the idea that you can not bulk export all FHIR resources, but you can export specific view definitions and get in the CSV format or like Parquet format what you need. So it could be much faster. Yeah, we're working on Parquet. We're thinking about query resource because like view definition plus query, it's a nice combination. So you can write the profile. Let's say blood pressure, you can write the view definition for this blood pressure, which make straightforward, and you can write a bunch of queries to do the reporting for hypertension or something like this. And so we believe it will become the part of IGs, and some will write these view definitions and queries, and another will run it on standard engines. So that's what we believe, how it's going to work. And we're working on standardizing API, and all engines will eventually support this API, so you can connect through the standard API to different runners. And especially Brian is working on FHIR Path Lab to embed the view definition designer. We have a visual view definition designer, and we need the standard API. Okay. So now let's jump to the real tutorial. Oh, maybe you have any questions? Okay, so let's do this. For those, yeah, we will run everything in Eightbox. So it's free for playing and exploring, no PHI data. Just we have a notebooks, and if you run the stuff, you can go to your browser, open the URL like readme, so localhost 8080. Just log in and you will get into Eightbox. Then you can go to the notebooks, and in notebooks you can search for SQL on FHIR with my name, and this is an interactive notebook which will walk us through the SQL on FHIR stuff. Yeah. So if you don't want to install it locally, you can go to eightbox.app and use a cloud sandbox for that. So everybody who want to like try at that point? Oh, should we wait a little bit? Yeah, just open localhost 8080. So when if you run in locally, you run Docker Compose up, and then open localhost 8080 in your browser. Yeah. Mm-hmm.
And then I go to the app. It's not local anymore.
Ah, you should register quickly. Sorry. But I can walk through this notebook like on okay, let's wait a couple minutes. So. Do you see the text? Yeah. Even bigger? Like this, yeah? So with this notebook, we can start with the loading data. So this is not standard, this is like a part of bulk import, which is not yet like published, but you can decrease the number to make it faster. Let's say you want to load just 100 patients from Cynthia. So decrease this number and you can run it. It will load from ND.json FHIR resources. So then you can test the FHIR API to see that you have something in your database. So then this is like just FHIR native stuff. We store all resources in the patient table, so you can see how many resources you have. I loaded before much more resources, so it's 11,000, but in your case it could be 100 resources. And then we can see how the resource is stored. So we're storing using binary JSON, so the whole FHIR resource is here in one column, and the rest are just special tables. And if you know the Postgres, you can make queries like this. So this is like FHIR pass from Postgres. So this is called arrow operation in Postgres, operator, and you can pick specific elements from nested data structure, and you can run it and use Postgres function. That's how we use like SQL on FHIR before our specification. And it still gives you a lot of flexibility because FHIR pass doesn't map it to the Postgres features one-to-one, and Postgres has much more. So check out like a Postgres JSON functions. There's a lot of interesting stuff inside. So that's how you can work with the nested data in Postgres. You can unnest arrays, you can search. There's a JSON pass, which is going to be ANSI SQL standard language to extract data from JSON. Yeah, but this is not going to be compatible. So this is you will do for your needs. So this is not about interrupt. Okay, yeah, I can read it for you. So here's a resource. There's a binary JSON, and we're using arrow operator. Oops, and we're providing the path. We can add something, for example, the resource status. Oh, I think it's active in patient. And we forget the extra comma. Okay, like this. Are you guys here? So who is trying? Or we will walk through that. Yeah.
Necessarily work out of the box, the Docker, your repo. It doesn't work out of the box for me. I had an earlier error. This is the current one.
Yeah, that is okay. Just open localhost 8080. Yeah, and then try to log in. And you have to. You can sign up with Google quickly.
Okay.
Okay, but let's walk through that stuff. Yeah, the name of the notebook is SQL on FHIR. Search SQL on FHIR and pick one with my name. And yeah. Yeah, there are multiple of them. Yeah, and you can decrease the number because this will load like 10,000 of patients, but you can make 1,000 or 100 patients. Okay, so then we're coming to the point when we want to create the view definition. So, and this is a very simple view definition for the patient when we say we just want patient ID column and taking ID, gender, and birth date. So you may run this, it will create the view definition at the same time, it will create the real database view with the name sof.patient, which is, and the name of the view will be like patient. After that, you can try to query this view, and you will get something like this. And this is already flat. And for example, if you have any database tooling, you can connect to the Postgres, and this tooling will recognize this as just a table and start like auto-completing your names and so on. Should I wait a little bit, guys? Are you? Huh? Creating? Ah, sorry for that. But then you can go quickly through the notebook. Yeah. So what's going on inside? So we can call this function in Postgres to see what's inside this view. And if we call this, you see that essentially we generated this view, this query from the view definition and the FHIR paths. And we can see when we are running the view, so what's going on in Postgres. So essentially, this is real view, so it's dropped down to the real actual patient table. But there are different options. So you can materialize this view, and it is always trade-off. You may want to run it on top of real view, but then it may be slow, and you could not build good indexes. So you can materialize, but then you have to refresh it. Okay, then we can create another view on top of this view. We don't have an age operation in FHIR paths, so that's, and we want to build a view with the patient demographic with the age. And when you run this, we're creating one view, patient plus, from the patient view, and we're adding the age expression to have age in the years. It's much easier to work. And then we can select from this view, and we have this nice view. But this is already just a Postgres, so this is nothing else.
So date arithmetics is not supported on limited FHIR paths.
Yeah, we don't have yet this function, but maybe we will add it. But it is always trade-off in SQL and FHIR because you can do a lot in databases. Yeah, so if you just you can export data you have and then like parsing dates, doing some stuff in database, and we always decide should we like complicate the view definition runners or we should delegate it to the database. And for example, we decided not to, in core doesn't allow to join. So we are not crossing the boundary of resource because the databases are specialized in it. Yeah? And it's very hard to be joining bulk expert because you need some very sophisticated runner to do that. That's why for now the view definition is limited with a specific resource type. And we're expecting that people will start joining inside database. Yeah. And now we can get some nice query, for example, like grouping by age and see the distribution. We can do some trick, for example, like divide by 10, round, and multiply by 10. So, and for example, order by first. So this is our distribution of patients by ages. in Cynthia dataset. And now we can jump to Grafana. So if you run it locally, you have a Grafana, and let's make the new dashboard. We'll add the visualization. So this Grafana already configured with the Postgres instance. So we may pick, for example, the pie chart. And so with such level of zoom, it's hard to write. Here we have to switch to the code, and we may say select gender count from patient plus group by first. Oops. I will make it a little bit smaller. Come on. Oh no. So where is this drawer?
Which part is the Grafana?
Huh?
Which part is the Grafana?
The Grafana should be on localhost 3000. Yeah. And the login is admin.
That's right.
Yeah. It's configured in a Docker Compose file. Come on, where's this drawer? It doesn't drag. Okay, let me refresh. Yeah. Count visualization, pick the Postgres, pick the pie chart. Here it is. Switch to code. Select gender count from patient plus group by first. Run, then we have to configure it here. So we say that we want to see all values. Now we see the males, females. We may say, show me the table on the right, show me the value, and yeah, that's done. So we can save dashboard. So what's wrong with it? Why it's not saving? Okay. And back to dashboard, we got this stuff for the genders. That's quite trivial, but it is something. So let's do something more sophisticated. So let's jump to our stuff. You can load conditions, so to make things more interesting. So you can decrease the number, because here I'm loading like 10,000 patients, so it will load like 500,000 of conditions. It will take some time if you do it. If you like reduce the number of patients, it will work. So then again, so we can look up through the conditions, and then we can flatten conditions. So we like very simple. We will take just onset date, another date, the clinical status, and here we will extract the SNOMED code and call it code. And just for us, we can extract the display from the code text. We will extract the patient ID and the category. And when you run this, it will create the view, soft condition, and we can see the count of the conditions, and we can select what's inside. So you see the status and all this stuff. And then, yeah, now we can write the interesting query where we're joining our patients with the conditions. We're taking age between 60 and 65, and we're grouping by display. We can group by, let's do it a little bit better. So we may say code and group by first and second. And then we can run this. Take some time, yeah. But we got this distribution by conditions. And we can, I'm not gonna bother you how to build this stuff. We will just go into prepare a dashboard. It's a part of this repo, so it's inside Grafana folder. And yeah, we can build a pie chart for different conditions. So it will look inside very similar. If we jump here, so here's a query. So we're joining patient table with a condition. We're taking only active conditions. We putting expression on age, and this $H, it means a variable in the dashboard. So we will be able to switch different ages. And we're making some sophisticated filter on gender with a special value any. And if it's not any, we will just make it for a specific gender. We group by display and order by count. So in taking 20, so top 20 diagnoses. And then in Grafana when you're working, so you can turn again. So it's a bug in Grafana. I will report. Yes. And you're getting something like this. So this is just a distribution by age, but we wrote this query, yeah? It's quite trivial, just grouping by age, but let's take a look how it looks inside. Yeah, so there's some SQL tricks here, which I already showed you. So we take date part, we round and divide and multiply by 10, so we're getting like buckets by 10 years. Okay, and now in Grafana you can go to settings, go to variables, and create the variable. For example, we have an age variable, and this variable is queried from database with this specific query and will be pre-populated with a bunch of ages from database. And the similar variable is about gender. And then in our queries, we can use this $variable to substitute. And we're getting this stuff, so we can, let's say, we can take the very children, any children, and see what are popular diagnoses. So, or we can take my age, guys, and see what are popular diagnoses for 45 guys. Or let's take the long-living human beings. Yeah, and we're getting something like this. As well, yeah, I did the same with a medication request. So we can take a look. In README, there is a medication request view definition. And I did the similar stuff to get this stuff. And you see like popular medications for different ages and genders. And it's just to like make you appetite. So it should be quite easy when you're starting visualizing, so and you really start liking this doing. In real life it will be much harder, like to write this SQL stuff, but we're getting closer to future. The Bashir showed you that LLM can do a lot for you, and that's really happening. So another example, so which is coming with this repo, it's who is programming in Python. Not so much, yeah, but like a lot of data science in Python. So it is coming with a Python. If you go to localhost all 8s, like forEach, it will open for you the Jupyter notebook. And here is a simple library, which is just wrapping SQL query into the function. So in Eightbox, we have a SQL over REST, but you can connect directly to Postgres, but yeah, we did this stuff. So if we eval this, we will have a function to query data, and we're wrapping it into data frame, the result. And then you can start querying stuff in a Python notebook. It will be converted to data frame, and then you can, for example, try to draw the pie chart. I don't know Python too much. I just asked it the cursor to generate for me the pie chart. And it was good, so it did almost, and even generated almost the right query for me. So, and what's nice about that, because SQL provide you much flexible access to the data. Yes, so when you start working with your like training models and all this stuff, you can join, you can aggregate, you can load into the Python, run some models on it, and again, so if it's flattened, so it is much simpler to work with it. So, okay, another example which is coming with this repo is a small JavaScript application. So we load it here. It drove the pie chart as well. Then we jumping into the buckets of the like passion groups, then jumping here, and then you can see up to the resource. So it's implemented the complete drill down, and the code is really very simple. So this is a one file JavaScript application. And it's doing this similar stuff what we did with the Python notebook. So I used Vega Lite. Who knows what is Vega Lite? No? So essentially, so again, so this dashboard is one JavaScript file with a couple of dependencies. And the Vega Lite is a DSL for visualization. So I can show you, it's like a FHIR. Oops, where is the Vega Lite? Yeah. So this is very nice library, and you programming with a JSON, like the view definition. So you're writing the definitions of your visualizations like this, and the library visualize it. And for example, LLM knows quite well the Vega Lite. And if we jump into the JavaScript implementation, what's happening here? So we just, So we just querying data and putting this Vega Lite JSON when we say we want pie chart, and we taking fields count and gender, and we want to do something on a click, and we just putting this small JavaScript snippet, and you're under the control of the whole dashboard. So feel free to make drill downs. 5 minutes, yeah, I almost done, yeah. So again, so this is just one file with like 100 lines of code. Feel free to extend it and play. It was boring for me to preparing slides, so I decided to write some ups. Yeah, so yeah, essentially that's it. So I can tell a little bit about this project if you run it. So here's a Docker Compose, which install for you the Postgres, the latest version. It will install for you the Eightbox, the FHIR server and database. It will install the Grafana. It will connect these guys together. So here we providing Grafana data source, which will be connect Grafana automatically to this Postgres. Here is a dashboards. You saw it will be available for you just as a sample. Yeah, so the notebooks are here. And yeah, and the small JavaScript application is here. And if you don't want to load all the data manually, there is a simple init JavaScript file, which will load in parallel data for you, create all the view definitions, and then you can run dashboard or working with a Jupyter notebook or something like this. So because I did this because it's like you should know all these details to put it together. So sometimes people spend like a couple of days to wire all this up. So I just did it for you so you can start playing with that stuff. And a little bit more about the SQL on FHIR. Let me tell them about other implementations. So this is our implementation. It's in Postgres, and we're still working to make it this part of open source. So we're gonna separate it from the FHIR server and make this just FHIR storage open source. So if we jump to the SQLonFHIR.org into implementations, so this is a reference implementation which is a part of the spec. If you go to FHIR, SQLonFHIR, here is a implementation in JavaScript. And the whole stuff is going on, I think, here. Yeah. So this is just 300 lines of code which implement the view definition runner in JavaScript. Yeah, and let's see. Let's come here. So here is the other. Here's a puzzling implementation. This is a Spark based implementation. This is something between ETL and ELT implementation. So very analytical solution. Yeah, so check out the puzzling page. So if you click on this stuff, so you can see how it works. So the general idea of the view definition comes from John, who wrote the puzzling. He came to the group and said, people want something flat. And we start doing something similar, and yeah, and we end up with a view definition. Bashir is here. So this is a Google OpenStack. So this is open source ETL transformation tools. And you can set up, run it, and yeah, check out the Bashir talks, like few talks about the Google OpenStack and how you can use this. So the Graham, again, so he implemented Runner as a part of Happy, and it's even available in IG Builder. So you can write view definition on canonical resources and then put templated SQL into your IG guides, and it will draw nice tables. So it's used even in publishing lifecycle. Yeah, the InCQA guys implemented something, so it's just the test results. I don't know, they probably didn't open source it. So I think it's in a Rust, very efficient ETL runner. So the MidPlum implemented the TypeScript. It's very similar to what we did in JavaScript. So the FHIR, I think it's some Optum guy reported something like very efficient ETL implementation, and the Dan wrote FlatQuack, which is ELT style transpiler view definition to the DuckDB. And if you don't know anything about DuckDB, you have to look into the DuckDB. It's like SQLite, but columnar. And it's very nice experience. So you're taking the CSV file and you can start writing queries with the DuckDB. So, and the DuckDB is really nice piece of software. So, and it's evolving very quickly. And they then did this FlatQuack implementation, which transpile view definitions into the DuckDB queries. Okay, and yeah. So I'm done. So find us on the Zulip, Analytics on FHIR channel. The main news are there, and in a couple of months there will be Analytics on FHIR conference.